Hello, everyone. Thank you very much for joining us again. We've again got an exceptional response with over 700 registrations for this webinar. So some of you have been joining us again. So in the last webinar, we concentrated primarily on patent searching. In this webinar, you'll see how truly big patent data is and what you can do with it in regards to business analytics. So so the audience that who has registered is primarily faculties. I've seen that 80% of the audience in the webinar are faculties who are scholars and doing research in their institutions. So we are going to see at the end of the webinar how IPGRAM helps solve some of the most common challenges in patent search and analytics. So if you have any questions on IPGRAM, then please, I hope the streaming is good. If you have any questions on IPGRAM, then please feel free to write me on my WhatsApp message. Now would be a good time for me to actually share the presentation slides so you can see. So yeah, you can see my WhatsApp number here. So if you have any queries on IPGRAM, please feel free to write me a message. If you're interested in IPGRAM, I can respond to you the first opportunity after the webinar, or if you have any general queries, I can also, during the course of the webinar, answer your questions. Feel free to also use YouTube chat. I'll take Q&A breaks from time to time. I'll read the chat messages on the YouTube app, and I'll also get back to you regarding those messages. So feel free to discuss among yourselves and also ask questions. So IPGRAM will be at the end of the presentation. First, I'll lay the groundwork on what what patent data looks like and what are the building blocks of business analytics within patent data. So IPGRAM is our own proprietary patent database. It has coverage of over 100 million patents from over 100 countries. India's top research organizations like CSIR and top business incubators are using IPGRAM for their patent and technology intelligence. We have over 3 terabytes of data on the cloud, and it is completely scalable to perform business in intelligence. So some of you have been joining us for the first time. So I'll also introduce myself shortly. So I'm Rahul Kapoor. I did my PhD in innovation management from Finland. And my PhD thesis was primarily based on patent data. So we were using large patent data sets to perform statistics, to validate patent value indicators, and to publish in top global business and management journals. I also have experience consulting firms like General Electric and Bosch in their global IP analytics. In the last decade, I have worked on in numerous technology commercialization projects, a wide variety of patent analytics use cases. My team has more than 30 years of experience conducting freedom to operate searches, prior art searches, and in general industry and technology landscapes and commercialization. So for the last 3 years, I've been running my own patent software and services company in Mumbai. Like I said, our main product is IPGRAM, and we will look at what IPGRAM looks like at the end of the presentation. So yeah, so let's begin without further ado. So if you are not seeing your chat, it could be also because that you've not logged in. So you have to log in with your Google account to be able to see the chat and then discuss. And if you're using your mobile phone, then probably it's better that you use the YouTube app rather than the browser on your mobile phone. Sometimes that causes problems and the chat is not visible. So yeah, I'll just check the YouTube chat and see if everything is going well, and then I'll continue. If you have any questions now, I'll just have a quick look, and then we'll continue like in a minute. Sometimes that causes problems and the chat is not visible. So yeah. Great. I think that everything looks good. So nobody has any comments that the streaming is bad or any there's no problem with the streaming apparently. So great. I think that this is a great time. We can start. So the agenda for the day, what you are going to learn and what we are going to cover. So the first thing is why we are going to use patent data in business analytics. So what is the inherent properties of patent data that makes it so good for business analytics? So we're going to learn some of the basic features. We are going to go over some patent concepts and some searching concepts. So these are based on hands-on exercises. So but don't worry, there will be instructions on the slides. So just you'll have to open some browser tab and run your own searches. And even if you don't want to run your own searches, by all means, I will also do it alongside you. So just enjoy the show, and we can also you don't really need to do those searches. And because I included this because these are the basic building blocks of patent analytics. Because eventually you will have to know what patent concepts are, what they mean, and to do the right kind of searching to be able to get a data that is relevant on which you will be able to perform business analytics. I've compiled some business analytics use cases in the slides, and also at the end, I'll show you some of the common business analytics use cases. And at the end, I'll show how IPGRAM overcomes common challenges in patent analytics and how we've added significant value to the free patent databases that are out there, like Espacenet, Google Patents, and PatentScope, and so on. So yeah, moving on, we are going to see what patent data really means, why it is so good for business analytics. So the rationale behind a patent, the most simple economic definition of a patent is that it's a reward given to inventors by the state in the form of a temporary monopoly. So this reward is usually a protection term of 20 years, and within which time nobody else but the applicant can make, use, offer, sell, or import, export the invention that is in question. So this temporary monopoly actually helps the inventor to draw the benefit of premium pricing. So because no one else can make, use, sell their invention, they are the only ones who can make some innovative product, and they are able to charge slightly higher prices to be able to recover the money and basically gain profits for the future. So some of you might be thinking, why to reward the inventor? So there is kind of a trade-off here because as we've learned in economic theory, uh, monopolies are usually bad. So they cause deadweight losses to the society, and neither the producer nor the consumer is well off if there's a monopoly. So, but the trade-off lies because it's an incentive to carry out research that may be very expensive. So, a case in point here is pharmaceutical companies. They spend billions of dollars in research trying to isolate molecules that will really help to form drugs for the future. And uh, there's a long process in pharmaceutical industry of trials, of approvals, and it can even take up to 10 years for them to be able to get approval on a molecule that they maybe invented like 10 years ago and to be able to start making profits. So for them, it's really important. It's an incentive that they will spend that much money, spend that much effort and time, so and get patent protection on what they have researched to be able to recover recover the cost of their R&D and to basically build profits on top of that. So that's one of the main trade-off. So for the temporary monopoly that the government is giving to the inventor, to the applicant, it's an incentive to carry out research. And there's even some research done that 30% of the pharmaceutical inventions that we see today in the market would not have existed had there not been a patent system. So the second trade-off, which is also a reason why you and we are here, is the disclosure clause when you are doing patenting. So because in order to obtain the temporary monopoly, in order to get the 20 years protection where no one else can make or sell your product, you are required to disclose your invention and explain in proper detail, and the patent data is public because of that. And because the fact that patent data is public, you and I here, we can perform loads of things with patent data. We can learn from it. We can perform analytics, which is the focus of this webinar, and so on. So anyone else can learn and improve the invention. So these are the two reasons why the inventor is rewarded, why a temporary monopoly is granted, so that users are going to, the applicants are going to actually innovate. So if you see this chart here, it's actually the filing trend in the top 5 patent offices. So you'll see that the temporary monopoly that I talked about, it really works. So the applicants, big R&D corporations, they are really excited by the fact that they are getting temporary monopoly, and they look at it as means to earn future profits. So if you do a macroeconomic research, you'll see that patent data or the patenting trend is closely related to economic growth. So China is really an outlier in this particular chart. But you'll see that over the last 40 years, in general, there has been a high demand for patents. So the demand is happening because these temporary monopolies really work, and the applicants and the companies, they really believe that they can make profits by obtaining patents and getting a monopoly and then pricing their goods higher. So you can see in the case of Japan, their GDP has actually even contracted for a large part of the last 20 years. And it also reflects in the amount of patenting that they have been doing. So in even in a country like India, there's a lot of push to do patenting. And in order for an economic growth to be sustained, a large amount of patenting is a must. So there has been even macroscopic studies 50 years ago that innovation is actually the main driver of economic growth. So companies are innovating simply because they want to get future profits and drive growth. So if you see this chart, actually, if you are interested, just for the trivia part, I took it from the WIPO IP stats. Actually, you can just go to the WIPO IP stats and actually build a lot of charts like this, and this really authentic data, and you can by all means use it in your reports and research papers. Uh, so yeah, moving on. Uh, just another metric to show you like how important intellectual assets are becoming in today's time. This graphic that you see here is basically the market value of S&P 500 companies and the component of it coming from intangibles as well as tangibles. So now intangibles can be anything. It not necessarily has to be patents. It can be trademarks, brands, software in today's time, or customer data in today's time, and so on. But you can see in back in 1975, out of the 500 S&P 500 companies, they had their market value primarily driven by tangible assets like inventories, human capital, raw materials, factories, and any physical assets. In today's time, in 2015, you can see that 85% of the intellectual assets, 85% of the market value is coming from intellectual assets. Now, I'm sure all of you've heard about this meme that Uber is the largest cab company in the world, and yet it does not have any of their own cabs. And Airbnb is the largest real estate company in the world, and yet they do not have any of their own properties. So that is kind of true. The thought there is kind of true. Uh, I'll just check on the chat messages if you are able to see the slides, just in case. So yeah, I think in the chat, I have not seen anything. Please change slides. Okay, 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 great. I'll just backtrack a little bit just in case anyone of you has missed anything. So I'll just also keep so these are the top 5 jurisdictions. You can see that China over here, it broke more than 1 million patents back in 2012. It became the largest patent office overtaking the US in around 2012. And currently they are filing more than 1.5 million patents in a year. And globally, there are about 3.5 million patents that are being filed in a year. Okay, moving on. So these are again another graphic to show some of uh, the, the importance of intangible assets in today's world. You can see that the S&P 500 companies that are there today, 85% of their market value is coming from intellectual assets. And again, this shows how important patents or intellectual assets in general are getting as we are moving towards the knowledge economy. Why patent data in business analytics? So basically, I'm going to summarize all the things that we just talked. so that you appreciate. So this slide is something that you will really appreciate uh, why patent data is so useful in business analytics. So, like I said, innovation is closely linked to economic growth. Hence, patent data can give crucial insights into future success of firms, future success of technologies, industries, and regions. So, because innovation drives economic growth, in principle, you have data in your hand that can forecast the future. So, one of the biggest use case for patent data is technology forecasting to see whether technology will rise or whether it will fall out of favor or another technology will overtake it. So we'll also do some examples on IPGRAM to see, how you can benchmark technologies, how well a certain company is doing or how well a certain technology is doing and so on. So this is one primary reason why patent data is so good. And the other thing is that players in the market, they fight for monopoly rights to get patent data, to get their patents granted. And this gives a view of the competitive landscape of technologies and industries. So when I say fight for monopoly rights, it just means that, everyone cannot get a patent. There's a long procedure to get patents. Getting a patent is expensive. Not every patent is granted. So, and also of the patents that are granted, not all of them are highly valuable. So, even though the demand for the intellectual assets is rising, but not everyone can get it. So, because of the fact that everybody is trying to get that monopoly, everybody is trying to get patents in their field of research, it kind of gives you already a good picture of the competitive landscape. So if I have to summarize business analytics using patent data, these are two of the most important reasons why patent data can be so good for business analytics. Simply because it gives you an idea about future profits and the current business competitive landscape that is going on. Moving on. Uh, Again, because of the disclosure clause, because of a high demand in patents, patent data, like I said, it's public. You and I, we are here simply because there's a huge repository of over 100 million patents from over 100 countries that is at our disposal to use it, to learn from it, to conduct tech landscapes, to conduct business analytics and intelligence and so on. So it's a massive source of public technical documentation that can be exploited. And that's what we are here for today. And just to, I think I said that already in the beginning, just to give you an idea. So IPGRAM currently houses 3 terabytes of data on the cloud, which is completely scalable, and it can give you one-click business intelligence of all the charts, and it can give you bulk downloads and so on. Okay. Uh, Now, there's just one question I'd like to pose to the chat. So it'll take just a minute. I'll just quickly look at the chat with your answers. So company A is more innovative than company B. How can you quantitatively argue the above statement? So how can you say quantitatively, like what pieces of data in general that is out there you can use to say that company A is more innovative than company B? So please write your answers in the chat. I'll take like some 30 seconds. I'll also look at the chat, and then we'll continue there. And it can be a point of discussion to see, how we can measure innovation. Okay, I see again that there are a lot of problems with slides changing. So I'm Yeah, okay. Okay, so I think I'll switch to the display mode. So I think this will help you to see the slides for sure. Yes. So I'm sure that now you're able to we are able to discuss. So yeah, this is just a general question to find out what are the different ways in which we can measure whether a company A is more innovative than company B or not. So yeah, some people have said profits on patents, new products, new processes, new features, and new innovative methods implemented by company A. That's true. Uh, and yeah, somebody is asking where is data from company A, and we know we right now are still yet to go into the data part. So yeah, it's just a general question on how you would measure the innovation, more patentable products or services than company B, number of unique ideas. Right, right. I can see. Okay, I'm sorry for the inconvenience, really. So I've switched to display mode, so my screen is now being shared instead of just the presentation slides. So I think that that should be all right. So yeah, so okay, the to summarize this question, the answer is that there are not very many data points available out there in the public domain where you can easily measure whether a company A is more innovative than company B. And patents are one of the best sources of data to measure innovation. And it's also easily available. It's rather easily available. Today we are going to see how anyone from the public can actually just go to patent databases and get data on these things. So yeah, I mean, a lot of you have also mentioned some other things like number of unique products, unique innovative methods. But again, to get data on the number of unique products, to get data on the number of unique ideas, so these all take a bit of effort, and readily these kind of data is not available. So again, just to emphasize the point that patent information is one of the best possible way to say whether a company A is more innovative than company B, and hence to draw implications out of it, that because the company A is more innovative, what can be in store for them in the future and so on. So yeah, okay, moving on. So this actually, I'll just summarize the whole thing in a kind of a very simple picture. So patent statistics is basically a field of research which develops the use of patent information. So there's a lot of patent data out there. Like I said, we have 3 terabytes of patent data in the cloud. There's a lot of metadata, there's a lot of citations, text data, classification data, a lot of data which you can create metrics out of it and really develop the use of patent information on what really it says about the company's innovative potential and their business potential and the market potential. So it can also help. This is where the task of a patent analyst comes. This is where the task of a business analyst comes. And which is basically to separate the wheat from the chaff. So you can see this picture that there are a lot of inventions that are out there, but not all of the inventions actually lead to patents. There's a lot of patents filed, but only about 60% are granted. And there's a lot of patents that are granted, but really few of them are really blockbuster patents, which really either change the world or really make a lot of profits for their companies. So again, with 100 million patents, it's difficult to really understand and access all the patents. So it is the job of the patent analyst or the business analyst to really identify the high value patents and conduct their analysis accordingly to really make sound business intelligence piece of information. We'll just move on. So the workflow of a patent analytics. So this idea I'm just giving in terms of business analytics part, where we'll also see where we can focus. So first thing that you want to do when you are using patent data for business analytics is to identify the goals of the customer or the goals of your team, depending on what you really want to see, and then you choose an appropriate database accordingly, whether it has the requisite coverage, whether it has the requisite quality in the patent information, and whether it allows you to do bulk download, because a lot of times you might have to download the data, do your own cleaning, and do your own pivot tables and so on to aggregate the data in the way that you find suitable. And then, of course, comes the searching part, where it's very important how your search is, because that search is going to define the quality of your underlying data, on top of which you will build an analytics. So we are going to concentrate on the search part a bit so that everyone has a basic idea about search. And of course, after the search, the point is to collect the data, clean the data if there's any mistakes, if there's any harmonization issues, or if there's any normalization issues or variances in the data, And finally, when you think that your data is ready, you can aggregate them, visualize them, segment them in different ways. So these last 2 points, it's something that IPGRAM automatically does for you. So really, it really saves a lot of man hours. So should you want to use, say, patent data in your research, should you want to put patent data in your research papers or any kind of business analytics reports, uh, it gives you in one click what kind of harmonization there are. You'll also see what I mean by company harmonization and legal status harmonization and so on. So yeah, so these are the basic elements, basic workflow of patent and analytics. And this is how typically an analyst will proceed to really make intelligence out of patent data. So yeah, okay, moving on. Key patent concepts and searching. So now just to get you an idea of what information is out there, where is the information coming from? So this picture that you see, it's a typical European patent application. And you'll see that there's a number of data points over here. So this is what we are capturing, and this is what we are able to query and aggregate and to present it in meaningful ways. So if you see here, the first is the filing date. A simple filing date can help you do a lot of different kinds of analytics. It can help you plot trend lines to see how many patents are being filed in a year, by a country, by a company, by in a certain technology, and so on. You can see number two, where the countries, the protection which has been sought. So this is a very good indicator of the markets for technology. So if a country is patenting in many different countries, you know for sure that they have markets in those countries, because inherently patent filing is expensive, and companies will not go to all the countries if they are not selling their products there. So it's a very good insight into the market aspects of technology. You can see here the patent applicant is Toyota. The title and abstract, you can see already by title and abstract, you can see that this patent is about autonomous driving. Technical classification is a way of classifying different technologies so that you make them very well searchable. We are going to learn about this in a bit. And you can also see many other pieces of information like inventors. And inventors are actually a good piece of intelligence for many HR personnel in the world. Actually, if somebody is working on the cutting edge of technology, they are very sought after engineers. So in this case, if you see the inventors over here, another company might be able to look at patent documents, search them on LinkedIn, and really, even a lot of hiring in top technology-oriented companies is happening by using patent in information. So yeah, so in short, in a nutshell, this is where the data is coming from. And there's a lot more data than what I'm just showing you here. There's citations, there's legal status, there's all kinds of representatives and so on. But in theory, this is what where we get the data, and this is what we are going to use. So okay, so one of the things, like I said, this is a very interactive kind of a webinar. So I'd like you to do this small exercise. So it helps you to get started, get warmed up on doing patent searches on your own. And so please take like a minute. And if you read this, in my early 1930s, Charles Darrow was unemployed and broke. In 1935, he invented a board game, and that gave him a lot of money later. So I'd like you to go to espacenet.com and search Charles Darrow board game. That's it. So just go to espacenet.com. There's a search bar at the top. And so I'm also going to do it with you. So just in case anyone wants to just view, I'm also going to do it to you, and then in just 30 seconds I'll just read the chat, and then I'll start with this exercise. Yes, patents alone are not giving more profit to any business alone, definitely not. Definitely not. So patents alone are not even the only measure of innovation. But the only thing is that because of their quantitative nature, they are a good metric. They are a easy to use data for measuring innovation. So I will mention this part actually in the later slide, that why it's one of the challenges of patent in information. So okay. So I think now I'm going to just do this exercise also. So I hope you can see my screen now because I moved to display mode. So I'm just going to type Charles Darrow. I mean, you can also feel free to write what board game we are talking about here. Uh, can anyone write on the chat message what board game we are talking about here? So yeah, if you can see my screen, I have searched Charles Darrow board game, and the first patent is actually the most relevant one, and you can see that it's Monopoly. It's already 85 years old patent of Monopoly, and still it is one of the most common board game that we see in today's time. It's a board game apparatus. That's correct. That's correct. So so yeah, that's the exercise. And you can see that if you want to learn more, you can also read description, claims. There's a lot of in detail this board game has been described. So we'll come to these things in a bit, just so that you kind of get an idea about what are the information that are out there, that is out there. And also, Espacenet in general, it's very cumbersome. And I'll also show you some of the good things and the bad things about Espacenet and how we've significantly added value to the patent search results that you get on Espacenet. So okay, I hope that you've been able to search for this board game and this Monopoly patent from 1935. And yeah, we'll just move on to some of the next exercises. So this brings us to a typical patent timeline. What I wanted to show you here what I wanted to show you here that patenting is not a one-shot action. So data is being created over a long period of time, and a lot of times the data is being used for real-time intelligence, and companies are monitoring each other's patents and even fighting for the patent right. So if you see here, there's the thing called priority filing, which is basically the first filing that is happening for an invention, and then uh, depending on the commercialization options available to the inventor, if they think that the product has global market, they will go to file the same invention in different countries. So basically, there can be different patents of the same invention in different countries, which are together called a patent family. And you'll see that there's a 12-month window on in which the applicant has to decide whether they want to go to foreign countries or not. And within 18 months, it's mandated by the it's mandated by the international treaties that all patents are published. So within 18 months of filing, we usually get them in the patent databases, and that's when the patents start to be visible, and that's when the we can do analytics on top of it. And you can see after the publication, there's a long examination process, and a typical grant of a patent is happening on an average, say for Europe, it's about happening in 4.7 years. So it's a long time before the applicant actually gets to know whether they can practice their invention or not. And during this time, an actual innovation is happening. The applicant is thinking about commercialization options. They are thinking about the potential of their invention. They're improving their invention, and they're making investments, say, in building factories and so on. So a lot of things. This part is a lot of action is happening. So, and even after grant, there are some uncertainties. Any third party can oppose a patent, and and even if you get a decision against you, you can fight the refusal of a patent. You can file appeals. Even a third party can file appeals. So this appeal period can even also go up to 5 years. So we are looking at a patent life cycle of at least 5 years, and if not, even sometimes 10 years. So this is where all information is continuously generated, and the top patent analysts in the top companies, they are monitoring in real time all the events that are happening during this life cycle and producing business intelligence from that. So yeah, so I'll give you like one more exercise for patent families, just so you understand. So I just explained to you, a patent family refers to a collection of documents protecting the same or similar technical content. So it gives you an insight into the global nature of markets. So patent families is one of a very good indicator of a high value patent. So if a company is having a patent and it is filing patents in many different countries, you automatically know that there's a global market, and hence this is a valuable patent, and you have some kind of a metric to measure the globalness of the patent or the globalness of the product. So, okay, uh, the exercise that I want you to do is simply look up Google's recently granted patent. So it's not recently granted. I think it's already been 2 years. It was granted, and it is based on a radar touch technology. So simply, there's a wearable devices are getting smaller, and there's no space really to use the touch screen on small wearable devices. So this pattern is basically you can make the touch gestures on in the air, and the device will automatically understand, say, what you want to do. Do you want to scroll up? Do you want to increase the volume? So you just need to make gestures in the air, and automatically the device understands. So again, all I need you to do is go to espacenet.com and search this patent number. So this patent number that you see here, US 9971415, it's the patent that I'd like you to search. And yeah, just let me know what the patent is about. Click on the patent family. I'm going to do it with you and see how many countries it is patented in. So yeah, I think I'll also do this exercise with you. So just let me know how many countries it is patented in the chat, if you find out. Yes, someone asked why pattern analytics is important for the organization. So, like we've been discussing, pattern data is a proxy for the innovative activities of the organization, as well as their competitors. So, innovation is strongly linked to future success, future profits, and future growth. And that is why, to be really into the game, an organization should have pattern analytics. So top organizations, they have it at a very high level. Apple knows exactly what Google is patenting, and Google knows exactly what Apple is patenting. So yeah, they are going to very large lengths to use patent analytics. So six, someone said six, and I think that is correct. So if you see, I just searched here, US 9971415. If you click on bibliographic data, you'll see the patent belongs to Google. It is based on a radar-based gesture recognition through a wearable device. So you can see the images here. The device sends a radar field, and then you can make gestures in the air, and the device understands whether you want to scroll or whether you want to do all kinds of things. And if you go to the patent family tab here, this is where all the inventions are. So China is there, of course. Europe, so they are going to Europe, so they might be going to many different countries in Europe. Japan, Korea, there are multiple US patents, and this is the PCT WIPO patent, which is a global patent. So yeah, six countries would be a good estimate. Even though with Europe, we don't know. So with eSpaceNet, there's not enough intelligence over here to really know in Europe which countries they are going to. But you'll see in IPGRAM, we can even say exactly in which country a certain patent is active. This because it is very common that applicant is not going to all the countries in Europe. They are only going to the most common or the major countries. So again, this is one limitation which we are going to have a look at. Okay, so moving on. I just built a simple chart from IPGRAM, and you can see here the global bioethanol players. So I searched up all the patents of biofuels, especially bioethanol, and these were the top players in the market. So if you see, I hope that the chart is visible. If you see that on the first column is the total patents, and on the second column is the total patent families. So patent families are basically, when you are doing patent analytics, when you are using patents for your business analytics use cases, you have to take a call whether you want to use patents, or whether you want to use patent families. So patent families are more of a proxy of the invention. So you can see the top company over here, Zyleco. it has so many patents, close to 2,000 patents, and yet it has only 90 patent families. So it is really not that big after all. But they have made a lot of patents in different countries, a lot of small patents in the same country, divisional filings as they call it, and this makes it very. Uh, this makes you actually see data from different perspectives to be able to see, because if you just do a count of patents, you'll get a wrong picture. So clearly Novozymes is the biggest leader in this field, and you can see pretty much all the other companies that are in the top 10, they are bigger than Zyleco. So again, this was just to show you that how much varies. So this is a typical use case where there's a huge discrepancy between the number of patents and the number of patent families. But in general, just to show you that you can get different insights when you count patents, and you can get a different insight when you count patent families. Somebody is asking, why are there multiple entries in each country? So patent system is rather complicated in many ways. So there are these things called divisional applications, where you can break one application into two applications. And that is sometimes the examiners are asking the applicants to do that, because one application becomes very broad and they want one application to define only one part of the invention, and the other application may be defining the other part of the invention. So there's a thing called divisional application, which is why you are seeing multiple entries in each country. So yes, somebody has written US, China, Korea, and radar-based gesture recognition. Yeah, it's a very blockbuster patent. I think it's not, the technology is not like in market kind of ready, but the thing is Google still has protection of this particular patent for up to 2026, or even more, up to 2036. And by all means, they are looking to commercialize it. And once it does, it might be a very blockbuster revenue making thing for them. So yeah, okay. So the global ethanol players, I think we'll just move on from here. So now we're going to talk about the technology classification, because a lot of time you don't necessarily will search companies, but you will have to search technologies. So I'll give you also some analytics aspects of technology classification. So this is something that you will have to use if you want to do macro level research, macro level charts and analytics on a certain technology. So I'll give you a few examples in due course. So inherently, what technology classification is, it's a zip code for patented technology. So just like you live in your certain area, which is divided in certain zip codes across the city, similarly technologies are divided into zip code kind of international patent classification. So it's a language independent method of searching for patents. Patents are global in nature. Every country has their own laws and their own formalities how patenting has to be done. And a lot of times it is a challenge to search patents in the original language. So pretty much all countries in the world, they are using technology classification, which is harmonious. And you can simply add a code and search for those patents. So yeah, so again, one patent can be classified into multiple technology classes, and you will see this example over here, and you will really understand how technology classes work. So IPC is a hierarchical structure of technology classification. So every patent has some technology classes. So even in the in the monopoly patent that you saw, even in the Google's radar-based gesture recognition patent that you saw, you have these IPC classes, and we are going to look for some more patents where we can see them. So as you keep going down the hierarchy, you keep defining more and more about the invention. So if you see, if you see that here, the section is F, which is saying that it's a mechanical engineering patent. Now it doesn't tell you much about the patent, but it generally tells you, okay, this is in the field of mechanical engineering. But as you go down, you keep getting more and more information about what the patent is about. So F0 is engines and or pumps. F03 is engines and pumps for winds. F03D is for wind motors. Actually, F03D is a very good technology class to find out wind power patents in general. So all things to do with wind power, like turbines, blades, the towers and the installation, everything that has to do with wind power and renewable wind power in industry, you can simply type F03D and you can get all the patents related to F03D. And if you go to the last level of detail, you can see that this patent is about a horizontal axis wind turbine. having multiple rotors. So if you are specific inventor working in this particular field, or if you are interested to know the technology trends only in this particular field, then you can simply take this IPC code F03D1/06, put it on any patent search tool, and you will get the intelligence of the entire industry in one click. So in IPGRAM, this is like in seconds, you can get an idea about this invention, all the possible charts and all the patents that are within this technology. I would like you to do one more exercise. For this exercise, I'd like you to go to this older version of Espacenet because it's more intuitive, and for beginners, you can know which field you are typing in so that you can find out. So what I'd like you to do is I want you to find patents in the field of wind power, which is F03D IPC, and the assignee has to be Google. So the applicant has to be Google. So we want to see Google's patents in the field of wind power. So for this, you'll have to go to this URL, espacenet, worldwide.espacenet.com/advanced search. So advanced search here is A is in small letters and the S is in capital letters. So this you'll have to just make sure, because otherwise it might throw up an error. So I'll just also do this exercise with you, and I'll also read the chat a bit and answer some of your questions. Yes, for every invention, people file multiple applications. Yes, this is a very common thing. So for even like blockbuster inventions, there can even be hundreds of patents filed for just that one invention. Yes. It is very expensive to obtain. Absolutely, it can, for a very global invention, it can even take up to 300,000 US dollars to file a proper patent family. Yeah, the cost range, yeah, up to even $300,000. But it depends on the inventor upon the choices that you want to take. So I did a webinar series on this last week on all the different patenting routes that you can take and what are the factors that you have to take into account to, choose this particular jurisdiction or this particular route. So yeah, it's kind of a uh, for a different session. So, okay, I think I'm going to do this exercise. And so here I'll just go to advanced search. And yeah, you can see here, this is the older UI. And here it's very intuitive where you put it. So in the applicant, I'm going to put Google. And in the IPC, I'm going to put F03D. That's it. That's all you need to do. You can press search. And you can see Google has 87 patents in the field of wind power industry. Now, you might be wondering that what is Google doing in wind power industry? Google is a technology firm, and but yeah, this is the thing that a lot of these tech companies, they are entering renewable energy for they have huge costs of their data centers. They consume a huge amount of energy, and Google especially has been interested in wind for a long time, and they have built even some products out of it. They want to power their data centers using ships in remote oceans to really have internet connectivity even in the remote oceans where it is difficult to get internet. I'm going to move back to the slides. And so you can see that Google has 87 patents filed in the wind power industry, which is quite a surprise. But it's not a surprise if you see this media coverage that Google has got. So they have this thing called these kites, which actually help in uh, uh, they are attached to the ship or any ground station, and the kites go really high up in the air and they rotate in the air. And there's a ground station which generates electricity. So they are they have made the prototype where they are going to install it in ships, and the ships will be able to power their data centers. So please let me know if everything's going fine with the live stream in the chat, and if you can hear me, because I see someone said that there's no audio. I hope that the audio is fine. Yeah, okay. So moving on. There's also a CPC classification, which is now gaining a lot of interest. Uh, I think that now you should be able to see the PPT. So we will skip the CPC exercise for now for the time. But again, CPC is a classification which is now increasingly being used. It is much more refined. It has much more technology classes than IPC. So for very precise searches, actually, I am even using CPCs. And CPC also has a new range of a new section called Y, which helps in finding climate change mitigation technologies and so on. So, okay. So this exercise, I will leave this video with you, so you can feel free to do it on your own. So in the old Espacenet UI, all you need to do in the applicants type Volkswagen, and in the CPC type Y02. So Y02 refers to all patents that are in the climate change mitigation technologies. So anything to do that helps in reducing climate change. So it's a very good class for doing research on, say, renewables in renewable technologies. And I can show you very quickly on espacenet.com. There's also a classification search where you can search these kind of classification, which is of interest to you. So if you go to, say, I will open both the so you can see here the classification search, and there's all these classes. So this Y02 is the one that I wanted to get your interest. So this is Y02, technologies or applications for mitigation or adaptation against climate change. You can go much deeper into it. Y02E is for greenhouse gases reduction. Y02E10 is for renewable energy generation. So all you have to do is enter these Y02E10 and you get all the patents related to renewable energy. Again, in IPGRAM, it's a matter of seconds. You can get charts, you can get trends, you can get the top players, and in extremely high data quality. So we will show you some of these examples where you will be able to appreciate how we provide high quality data. Okay, so please feel free to search Volkswagen and Y02. So you'll find out, say, all the patents of Volkswagen in the field of Y02 or climate change mitigation technologies. Yeah, okay. In the new Espacenet, this is the query where it's rather cumbersome. You have to type these PAs, patent applicant, CPC, and so it's not very complicated. But then, as a new user, it's a bit difficult. The Espacenet. So patent claims, we are going to do one more exercise just before we move to IPGRAM, and I show you how we do the analytics, how we have solved some of the biggest challenges in patent analytics. So, okay, this patent claims is basically, uh, now we know that patents are intangible assets and it's kind of a knowledge-based asset. So it's difficult to identify boundaries of an intangible asset. For a property that you own, which is a physical asset, it's very clear that you have a certain dimension, certain width, and a certain length that you own, and something outside that you do not own. But in patents, these boundaries are defined by patent claims. So claims are going to define exactly what is protected by your patent, all the technical part that is protected by a patent. And if there's a product in the market whose technical features are overlapping with your patent claims, that is where an infringement happens. So a lot of people, it's not clear for them how infringement happens. So this is it. A patent will never infringe another patent, but only a product can infringe a certain patent. And in this case, like a smartphone is made up of thousands and thousands of patents. There are so many different technologies in a smartphone, and combined, all of these technologies are becoming one product. So it is quite likely that if a smartphone is infringing a patent, it will be only part of the smartphone or the small part or the small feature of a smartphone that will infringe somebody's patent claims. And that is how judges, lawyers, attorneys, they identify patent infringement. And depending on that, the courts argue and decide on damages, and the and the trial is decided around patent claims. So patent claims are really important. There are two types of claims. I think that again, we won't go into the details of claims because our primary focus is analytics and how to build charts. And by all means, I'll leave you my contact information at the end. There's also my contact information at in the description of the YouTube video. So by all means, feel free to get in touch with me, and we can discuss your use cases and proceed accordingly. So there's one more exercise where I'd like you to find Espacenet's Go to Espacenet again, just the new version is fine, and type this Facebook's highly cited patent. So this is a Facebook's patent back in 2011, where they patented the tagging feature, where you could identify certain parts of the image and you can tag who this person is and assign metadata to an image. So I'd like you to go to this patent and click on patent claims and just tell me in the chat how many claims there are. So just go to espacenet.com and search US 2011 202531. That's all. So I'll do the exercises with you and read the chat at the same time. So please feel free to write in the chat how many claims you've seen in this patent. So yeah, this is the Facebook patent tagging digital media. And you can also see the IPCs and the CPCs over here. So the classifications are also there. You can even click on these IPCs and find out what they are about. So you can see, I think, yeah, this one CPC, it says retrieval characteristics by using metadata. Metadata not derived from the content or metadata generated manually. So this is the tagging feature of Facebook where metadata was generated manually and the image was classified as having who the participants of the image were. So if you go to the claims, the part of the exercise is simply you go to the claims and you see how many number of claims there are. You'll see here what is claimed is. And this is, again, like I said, the most important part of the patent, where you see exactly what is defined. And if you scroll, you'll see that there are 22 patent claims. So there are 22 patent claims of this particular patent. And if you want to think of this in the perspective of big data analytics, then claims are a good metric of the width of protection. Just that length and width are the boundaries of your physical asset. If you have more number of claims in the research literature, it has oftentimes been shown that if you have more number of claims, you have a broader patent and hence your asset value is higher. So you can even draw metrics where you can see the average width of the claims of a certain company to identify whether they are having broader protection or an extra protection. Uh, 22 claims, right? I think most of you have got the 22 claims part. So yeah, so there are 22 claims, and we'll discuss slightly about patent citations, and we'll go through a little bit about patent searching, and then I will move to IPGRAM in like 5 minutes or so. So patent citations, again, it is something that is there in most apps, but the way we have aggregated, we've basically inbuilt patent citations inside user searches in IPGRAM. So patent citations are very similar to research citations. If you've written research papers or you've read research papers, you'll see that there's at the end a list of references. So similarly, the patent inventors are obligated to show the examiner where they have learned. And so there's a compilation of list of citations. So examiners are also, during the examination process, they uncover citations, and it basically helps them to identify whether a patent should be granted or not. So patent citations are give you a good idea about knowledge transfer, who's learning from whom. So I'll give you an example of Apple's smartwatch, where citations were an early indicator of the fact that they were about to launch smartwatch, even when the rumors had started to come. So if you see this picture, it summarizes citations in a very simple way. And you can see patent A, which is the frame of reference, it is making citations to past patents. So patent B, C, and D, they come in the past, and patent A has cited them. So these are backward citations, patent B, C, and D, in reference to patent A. Patent A, on the other hand, has received patent citations from X, Y, and Z from future patents X, Y, and Z. So these are classified as forward citations. And again, if you change the frame of reference from the frame of reference of X, Y, and Z, patent A is backward citation. So these backward and forward citations are a very good quality tool, which you can use to draw intelligence, to draw the knowledge flows, which company is learning from whom, how much overlap there is between portfolios, to find similar companies, and so on. So yeah, in this lecture, we won't be able to cover all possible use cases of citations. But yeah, in future lectures we can concentrate on certain things and proceed accordingly. So yeah, this exercise again, I think I will, we can make this as the last exercise before we move on to IPGRAM. So this is Apple's highly cited touchscreen patent. It's back from 2006, the capacitive touchscreen. And it is one of the most blockbuster patents on which the entire smartphone industries has been built. And what I'd like you to do is simply go to the espacenet.com and type this Apple smartphone touchscreen patent. So to US 2006 026521. So it was filed in 2006, and I want you to see how many forward citations it has received. And yeah, that would be great if you could mention in the chat how many forward citations it has received. And after that, we can move to IPGRAM slides, and I can also show you how IPGRAM helps you do business analytics. Yes, can you please clarify how more claims are good? So this is a very contentious topic. More claims are not necessarily good. There's also a thing called independent claim and a dependent claim. So it is usually considered that if there are more independent claims that define uh, the broad technology aspect, it is a good sign that it has more independent claims. So I would say not in general claims, but if a patent has more independent claims, it is likely that it is having broader scope, and because it has a broader scope, it is able to infringe more patents, and hence it increases the value. So okay, I'm going to also search this US 2006. So over here, 026. So yeah, these are gestures for touch sensitive input devices. So this is again, like I said, it's one of the most important patents. And here I'd like you to go to the citations tab, and forward citations are ones that are coming, that are citing this particular patent. And you will see actually the list is so huge that it's taking time for this patent to even fetch all the citations. So if it comes, we'll have a look at it. Otherwise, we'll just move to IPGRAM. And of course, you can also mention 100 claims. Okay, yes, yes. I haven't checked the claims, but yes, it may be even having 100 claims. Yeah. So yeah, you can see the citing documents here. And it says here that the list is too big, so we have to make a separate search. But anyways, we can see 1,298 patents have cited this particular patent of Apple. And that's why this patent is highly valuable. And forward citations are one of the best indicators of patent value that is out there. So, okay, I think that now I'll move on to IPGRAM. Yeah, okay, 100 claims, but I haven't seen 2096 cited. Yeah, okay. So I'm going to move to IPGRAM now, and then we're going to see, how we are using IPGRAM to solve the most common problems in pattern analytics, and how we package the information to such a level that you really need a couple of clicks, and you can directly import the pictures or directly import the Excel files and use it in your own research papers and so on. So yeah, so one of the main things that you will see in IPGRAM is for any search that you conduct, we don't just show all the list of results. So some of the searches that you will do in Espacenet, you will see that there are 200,000 results. And any normal person cannot even think of, looking up all those 200,000 patterns in a list. So what we do is that whatever search you conduct, we make it into a tech landscape. So even if it is a very precise search, having very precise keywords with just 200 hits, or it can be a very broad search with multi-industry and multi-country search with over 20 million hits. We will treat them all the same, and we will aggregate the information in charts. That can be used to produce tech landscapes or view the data in a way that helps you consume more data to go only where you want to go to check out the most important things. And it also helps you to validate your searches. So if you see the right technology classes coming when you're making searches, you know that your search has been correct, and you can build your first search and make it into a second search, which is having more, which is more refined, and use your third search to build upon your second search, and so on. So again, you'll see that we can generate tech landscapes in seconds, and all the information I will show you on the app. The other thing that we are doing is that for every patent that you see on IPGRAM, we have a real-time legal status. So the legal status data is being updated every Thursday of the week. So as of today, you can already see the legal status, which has changed yesterday. And in Espacenet, when you search the patents, you will never see what the legal status is. And when you do see the legal status, you only see a bunch of codes that make no sense. So we have interpreted over 4,000 legal status codes from 44 countries. And we have packaged the information for you, which says the patent is active or lapsed or it's pending. And you can see in this picture, you can see that in European patents, we can even say which country a certain patent is active in. So it is very usual that applicants are not seeking protection in all the countries in Europe. So in this case, you'll see that it's active in a certain few countries and lapsed in all those countries. So this is the value add that you get. Whenever you see a patent on IPGRAM, you can instantly get an idea. And this is vital for creating freedom to operate searches. If you have 20 or 30 very important patents related to your invention, it only goes in your freedom to operate list if it is active. And the only way to find out quickly is to simply go to IPGRAM, say import your list of patents, or you can even search on IPGRAM and find that list and make a freedom to operate search. Moving on. So one of the things, again, that is inbuilt with all your searches is patent valuation. So we have used some of the best practices in patent research. We know that patent data is coming from different countries. All of these different countries have their own idiosyncrasies. So we've made sure that all the different laws, all the different jurisdictions, whatever the variances are there in the data, we have normalized it. And so you will see that all the simple metrics that we have on our app, like forward citations, they're completely normalized. So making sure that in US, for example, it's very normal. Patents get 4 to 5 times more citations than countries in Europe. So this way, we are making sure that a patent that has got 5 times more citations in US is comparable to patents that have not got that many citations in Europe. So by normalizing all the variances in the data, in technology fields, in the year, and as well as the country. So this also helps you. Benchmarking is a very simple way of comparing patent portfolios. You can see what are the stronger technologies. You can see what are the stronger companies, which companies are having which strength and which companies are having which weaknesses. So at a glance, you don't just see a list of patents, you also see aggregations where you can really see whether a company is more innovative or less innovative, or in which aspect of the portfolio strength it is innovative. Another thing that we are doing, which really is like vital, and if I run a simple search for you on Google Patents, you will realize how difficult it is to manage the company ownership. So what we have is that we have our own proprietary ownership database. We have harmonized more than 2,000 companies. If you see the picture on your right, this is how patent data looks, and this is how the patent data in general is. So it's not like we are getting the patent data in this way. In general, Tata Steel is having many different subsidiaries in different parts of the world. So what we've done is that we have collapsed all these subsidiaries, which are having different naming conventions, into one entity called Tata Steel. So all you need to do is type Tata Steel, and you are sure that you are getting the most accurate, comprehensive coverage of Tata Steel's portfolio. So this small aspect is something, while doing my PhD, I used to do it manually. I used to download large data sets, and I used to clean the applicant names manually so that I'd be able to generate charts that are of high quality. And this is something that we've inbuilt in IPGRAM. you don't need to worry about it. We have quick turnaround times for even harmonizing new entities. This especially saves multiple man days. Even if you think about one project that you do in 1 week, uh, uh, with manual harmonization, it will take you 1 day to do what you would do in 1 week. So, and you can completely trust the data and directly post the data on your research papers or your essays or any kind of business analytics requirements. Uh, then there's a very simple thing that, again, innovation is not one shot action. You need to save your patents, you need to save your queries. So we have a place where you can save all your small patent data sets. You can save unlimited patent data sets. You can top them up with new patents as you find. You can share with your colleagues. You can export lists and send Excel files to your colleagues, and so on. So there's a lot of options of just something as simple as saving. So in a lot of free tools, it's difficult to save your patents. And I'll tell you, it is a normal thing that you do a search today and you come back to it after 2 hours, or you come back to it after 2 days. And when you search in Google patents, it's just lost. So you'll have to start over. If your search was very complicated, you will have no place to save it. So this is something we have, inbuilt in our app. There's advanced citation analysis, which is based on aggregated site citations. Simply, you can get intelligence at once who are the top competitors in a certain technology field, whether there are chances of infringement, and in general to even see the practices of backward citations and the intelligence that it gives. So there was this case study of Apple where Apple was starting to cite Swiss watch manufacturers even back in 2007, and their own watch product was launched in 2011. So like the latest backward citations is a good indicator of where the technological trajectory of a firm is going. So in our case studies that we have done for our clients, we've also seen that there are some companies who used to be in a different industry, but they are now citing companies who are in a completely different company. And slowly, say, a paper and pulp company is becoming a chemical company. So this is some of the things that you can get intelligence from backward citations to see the real technological trajectory as early as possible. So just a few notes on IPGRAM. We have best-in-class data. We are building our patent database on top of Espacenet's, exactly what Espacenet has. We are getting our data from the EPO, and we are adding our own Indian database. So we have one of the best coverages of Indian patent data in the world. Very few companies are having that high quality of Indian patent data. And even Google Patents, Espacenet, they are not having a comprehensive Indian patent data. So we are having the latest legal status data from 44 countries, high quality ownership data, which gives you instant charts, instant top players and competitive environment. And we have bulk data downloads. At once you can download 10,000, and in a day you can download up to 100,000 records. So chemical searches, yes, ma'am, yes, sir. We do have chemical searches via Inchi keys, and yeah, so Inchi keys and the smiles representation of the. So yes, I just said about the download limit. So can you use IPGRAM data in our research on your research paper? By all means, we already have citations coming from different universities abroad who are citing IPGRAM as their source of data. We are built on one of the most authentic databases for business analytics and statistical analysis. And yes, Indian patent data, yeah, we even have Indian patent data up until even the last week. So we are rather fast in developing the Indian patent data. So yeah, these are some of the small features. And now we have leading research organizations who are using IPGRAM. We have a lot of universities abroad who are using us. Some top incubators in India, top research organization like CSIR who are using, and there are some even industrial research organizations who are using IPGRAM. And they use it to validate the patentability and marketability of ideas. Innovation starts much before a patent is actually filed. So at all times, it helps to do a patent search, identify your commercialization options, identify the markets and selling features and so on. You can also find out in IPGRAM what can be the new application areas of your technologies. So if you see that when you conduct a tech landscape, we segment it. I'll just show you in a moment. You can identify the partners with whom you can collaborate. You can get probably funds from them. later sell them your patent, or even get them as outright customers. And in general, we have high quality patent data. So feel free to use it in research, download the charts and put it in your research papers. So again, there is my WhatsApp contact number. So just in case that if you have any queries on IPGRAM, now would be a great time. Just write to me, and the first chance I get after the webinar, I'll get back in touch with you. For any general queries, by all means, I can even answer your questions now. So now I'll move to the IPGRAM app just to show you how it works and some of the main features around IPGRAM app. So you can see here, this is the tech landscape section. One of the most basic things that IPGRAM has is simply a search history. I mean, it's a very basic thing. All the searches that you have performed, it should be there in one place. And if you have very complicated queries, you can even save your queries and retrieve it. So right now, I'm going to just retrieve a query, which we did for a project a long time ago. And it was based on nanocellulose. So nanocellulose is one of the emerging renewable materials. So it is based on pulp, and it has the potential to replace many materials today, which are made up of fossil fuel related plastics, or any material which has fossil fuels used for their processing. So this is, say, the technology trend. So instantly you can see a trend line, and you can see the 5-year compounded annual growth rate. And all these charts that you see here, you can see what technology classes there are. You can see the description of those technology classes. And this also helps you to validate whether your search is good. And sometimes there are incorrect technology classes which come up, and then you know that some mistake has been made. So for example, I was doing a search where I was looking for oil-based cooling, and I was getting a lot of lubricant-related patents. And this was because lubricants are also oils, and hence they were appearing. So then I knew that, okay, something was incorrect, and I changed the presentation. So yeah, and every chart element that you see here is drill downable. Immediately, you want to see, say, the top players, Stora, and so their 389 patents. You can simply click on it and drill down and see the 386 patents. And every patent that you see in the database is clickable. Here you can see the entire family members. You can see the claims. You can see also that we have interpreted the legal status of this particular patent. And immediately you know whether a patent is active or not. So you can see the claims, and we have one of the fastest translation. Immediately you can translate any language to any language, and so on. There's like a lot of features in just patent claims. Then apart from the landscape view, of course, we have the normal list view. The list view is basically the same as what Espacenet and Google Patents will give you. But we've made a lot of improvements here where all the patent members are clubbed into families. We have different sorting by relevance score. So you can see here that all the family members are collapsed into one, so that it reduces redundancy and your time taken to really evaluate a certain patent. So you can see here, this is an Inventia patent. And again, for European patents, we can say also exactly in which country it is active. We are interpreting it based on these codes. You can see this is a post-grant fee payment code. So quite recently, this was 1st of May. So even last week, we got a post-grant annual fee payment made in Portugal. And so we have marked that Portugal is the active country, and for at least next 1 year, this will be active. So even like for 44 countries, we are getting this. So based on renewal fee, we know that on 27th March, this renewal fee was paid in New Zealand. So we know that they have protection in New Zealand. So this way, at once, you can see all claims description, family members, and citations to a certain patent. And instantly you have all the intelligence. And whenever you have patents, you can select them one by one, or you can select them all at once and put them in a list. So you can see I have like hundreds and hundreds of lists working on different projects. And this helps because, all these 4,000 patents are not useful. So whenever you see them from the relevance list that, okay, some are useful, just add it one on top of the other. And you slowly build a list that you will use later. It is something, a very basic feature, which most platforms don't have. And of course, you have all the download possibilities. A lot of indicators are there, which you can simply click and download up to 10,000 applications. You can enter the entire search result to a list. If you select a old list, it gets added, or you can create a new list. I'll actually show you one feature where I have made very sophisticated queries on artificial intelligence patterns, and I want to compare different technology segments within those artificial intelligence fields. Then we have the portfolios tab, which gives you a very good idea about the strengths and weaknesses of the portfolio. So here you can see Stora Enso is the largest company, have the highest number of patents, but they don't necessarily have the largest number of patent families. Some of the Japanese players have the largest families. And if you sort by patent strength, you will see that some of the smaller companies like Inventia, they have just 6 patent families, and they have a much higher portfolio strength than some of the other companies here. So if you are interested, I will be happy to tell you in the future, all about the portfolio strength, all the high quality research normalizations that we've done to the data, which aggregates the best practices in research and the most highly correlated patent value indicators are used to give you a composite score on the portfolio strength of a certain company. So this is again, top companies use it a lot in their management presentations. So by all means, this is one of the most authentic ways to present, say, even in your research papers or in your management reports, what the industry trend is like. So and again, you can see there's a lot of grid ways. You can choose a lot of different metrics on which you can make graphical uh, presentations for any technology field. And this can be done, this is just 4,000 results. This can be even done for up to 20 million results without any problems. So you can say, just enter the entire Chinese patents and do the same visualization. So I just enter China here, and you'll see that within a matter of like seconds, we will be able to build visualizations on 9.8 million patents. And all the features work normally. You can drill down here, you can see the portfolios and see exactly on which technologies China is patenting and so on. And there's a host of other features where you can find uh, different ways of segmenting your patents. So I'll just show you a couple of them because we probably won't have enough time. So you can see here, these are the nanocellulose patents. And instead of applicant, you can choose a tech field. You can see all the different technology fields on which patent can be classified. So you can see that nanocellulose is being used in so many different technology areas. If you want to see just medical technology, just click on it and you can see the 327 patents. Medical dressing, wound healing, it's one of the most common use cases of nanocellulose. And you can even save all of these patents to a list and just keep it in a list, and I'll show you how you can use it. So we have machine learning based topics. So any search that you conduct, you can see the top topics in the field that are emerging and see the different portfolio strengths of those. I will just show you one or two more examples in benchmark. Uh, I will answer some of these questions. So about the subscription cost of IPGRAM, someone has asked. So it is a proprietary database. So we have our cost is very nominal. So with say our competitors, it's even 1/4 the price of our competitors. So our price is very nominal, and so by all means, I will have to understand your requirements, and I can tell you more about how it works. And how does IPGRAM compare with Derwent? I mean, these are really two different things. I mean, Derwent is a very highly, like, it costs in lakhs and lakhs of rupees, and it's a very B2B. It is done on an organization scale, and I know my colleagues have worked in Derwent, and I know a lot of things that IPGRAM can do in 1 second, which Derwent, you will have to have a training session for a week, and then you will be able to get a certification or an expertise to be able to conduct an analysis. So IPGRAM will get your job done in 2 seconds. What you would have to say learn all the features in Derwent. So, and we come with complete support and search and training package. I'm happy to take it further. Please drop me a WhatsApp message, and we can have a look at it. So I'll just show you, like, from a business analytics perspective, one very important thing before I conclude this session. So what I did was that I ran a lot of queries on artificial intelligence. So artificial intelligence is especially tricky. It's not a technology. So So it is difficult to find their patents in general. So, but I find some ways, and I sub-segmented artificial intelligence patents. So basically, I sub-segmented them into three different technologies: classification, fuzzy logics, and neural networks. Uh, so I can share my queries with you if you are interested also in doing this kind of a research. So what I am doing is basically looking at all three different artificial intelligence subfields, and my goal is to see how well they are performing in terms of each other. So within the field of artificial intelligence, what technology is like the highest and what technology is the lowest. So you can see here artificial intelligence neural networks related patents are really taking off. In fact, the whole field of artificial intelligence is taking off. And back in the day, there was a lot of classification related patents. So this comprises of k-means, support vector, random forest, and many different classification related patents of AI. And but nowadays it's neural networks who have the highest patent. So this over here you see is a quality versus quantity chart. So on the x-axis is the quantity, the total number of patent families, and on the y-axis is the overall quality, which is our own metric based on forward citations and normalizing them with all the variances in the database. And we are able to average out the global forward citations and tell you that the bubble size is the total portfolio strength, which you also saw in the metric in the portfolios. So you can see the bubble size is higher, despite having fewer patents. AI neural networks is actually the bigger industry over here. So this is also a way of presenting your results to basically compare technology ABC, which one has more potential. And you can download all these charts. You can download Excel files for the data and just simply use it in your research papers and so on. There's a whole lot of features. I will not go into the details of lists and a lot of citation-based features in here. We also have a smart search feature where you don't need any operators. You can simply put in keywords, entire paragraph of text. So I'll just leave you with this. So suppose you want to search for solid state batteries in the world. Simply, you just enter the search result and you will get the entire list of patents within. Uh, and the most relevant patents are here at the top. So you can see Fujifilm, Apple, Panasonic, these are the top players in the field. If you want to see separately, okay, you're interested only in North Europe and North America, you can simply enter loads of text, entire paragraphs, or mix and match with IPC, CPC, applicant names, inventor names, and get these. So you can see if you want to find partners, we look at not just the top players, but players that have the most solid, most relevant patterns related to your query. So you can find potential people who can be sales targets or just collaborators, or somewhere you can also file joint research projects and raise money. So this is also one of the use cases with which IPGRAM has been used to identify partners with which collaborative research projects can be made and joint funding can be obtained. You can also see technology fields. So solid state batteries are going into many different technology fields. And transport is like not, there's a lot of action in the transport field, but solid state batteries are still not prototype, it's still very prototype level in transport. But there's a whole lot of industry based on solid state batteries and solid electrolytes within batteries. So yeah, this is a very simple way of searching for patents. And if you want to qualify your idea, simply put in text here and you'll get so all the intelligence it needs. So with this, I'm going to wrap up the presentation. And at the end of the presentation, I can say that if you would like to have a free trial of IPGRAM, please write a short note to us and about your patent analytics and patent information requirements, and we can arrange it for you. And these are my contact details. Please feel free to email me, add me on LinkedIn, or write me a WhatsApp message or call me on this phone number. If you're interested in IPGRAM, by all means, please write to me, and I will take the first opportunity after the webinar to be able to get back in touch with you. So I'll just read the chat messages for one last time, and then I'll try to answer as many questions as possible. The e-brochure, it's possible to send. Yes, the PPT, I'm afraid no, because it keeps changing, and I don't have a specific PPT for any. So, so yeah, the e-brochure of IPGRAM, by all means, I can send it to you. I'll just look for some more questions. I think I've answered most of the ones from the chat. And And someone messaged me. I'm getting a lot of messages also on WhatsApp. Uh, so yeah, something about subscription and uh, country-wise patent data someone has asked. So yes, you can actually search more than 100 countries, and India is included. We have more than 500,000 Indian patents, as opposed to only 80,000 that Google Patents has. And 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 yeah, so our coverage is very comprehensive. So it's not a problem at all. IT India. So yeah, I would like you to before I leave, just I'll be grateful if you can submit on the feedback form. So Yukta from my team, she will send you a feedback form also in email, and probably I will also update the feedback link in the YouTube description. So just please take a moment and write the feedback. So the time was a little bit short, so I'm afraid I'm sorry if we could not cover all the aspects, and there were a bit of technical glitches also in the beginning, for which I apologize. But by all means, we are conducting these webinars on a regular basis. Next week, we have a patent search and analytics webinar, which will be concentrating on the search aspects of IPGRAM. So by all means, we can send you a link for that webinar too, and we can explore not just the analytics part, but the 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 solid search features that we have, and over and above what what Espacenet and Google Patents are offering. So, okay, with this, I will take your leave. Please take a moment uh, to fill in the details in the feedback form. I will update it immediately, and have a great rest of the day. And I look forward to getting in touch with you, and also having you and hosting you in other webinars. Thank you so much, everybody. Thank you.